myself Pragati Zara, Assistant Professor, Department of Statistics in PDP College, Task. Today's lecture we discuss the topic related to statistics, that is statistical quality control. In that lecture we discuss the following points. First one is need of statistical quality control, type of variation, type of control. Next one is type of control charts and control limits for R charts. Let's start from the first point. Need of statistical quality control. In competitive world, we see that the success of manufacturer is wholly depends on the quality of product. Then what is mean by quality? Quality means fitness for use. As we say, product is of good quality if it is satisfied the required specification of the consumer. But next one, what is mean by statistical quality control? By using statistical methods, we have to maintain the quality of product in a continuous flow of production. But it is essential that product should possess the exactly same quality that consumer wants. But it is not possible due to some type of variation. The variation in the manufacturing process are present due to two types of causes. First one is chance cause and second one is assignable cause. Chance cause is a random type of variation which is inherent and it is not prevented, so it is also known as allowable variation. Next one is assignable cause. Assignable cause is a non-random type of variation which present in manufacturing process in systematic way, so it is called as assignable cause. Assignable cause include factors like, first one is raw material of bad quality, improper setting of machine, wrong handling of machine or machine defects. Any of these factors are included in the manufacturing process, then we conclude that in manufacturing process assignable cause is present and which affects on the manufacturing process. So next one, we have to control that type of causes. Next we see type of control. There are two types of control. First one is process control and next one is product control. Process control is achieved through by using control charts, and product control is achieved through by using acceptance sampling plans. In this lecture, we mainly focus on process control. So let's begin with that point. What is meant by control chart? Control charts is a graphical device to detect presence of assignable cause. Then what is the nature of control charts? We see this is the graphical nature as we know. Along x-axis we take sample subgroups. And along y-axis we take statistics. As parallel to x-axis, we draw three lines. First one is CL, this is the central limit. Next one is LCL, this is lower control limit, and this is the UCL, which known as upper control limit. These 3 points or 3 lines are calculated by using probability distribution of statistics. Then what is the interpretation of control charts? All the points are falls within the control limit, that is above LCL, above lower control limit, and below LCL, UCL, that is upper control limit. Then we conclude that whole process is in statistical control. Next, any of the point, for example, one point is false here or any points are false here, then we conclude that the manufacturing process is out of statistical control. That means some type of assignable cause are present in that process. So what are the control limits? Then we see sigma control limits. That is CL nothing but expected value of T, LCL nothing but expected value of T minus 3 times standard deviation of, and value of UCL, that is upper control limit, which is nothing but expected value of T plus 3 times standard deviation of T. Then what is value of T? T is the statistic which is based on sample observation. Then we go for type of control charts. First one is variable control chart. And next one is attribute control chart. If the characteristic under study is quantitative, then we use variable control chart. Quantitative means like the height of product, weight of product, or length of the product. These are the quantitative characteristics. Then we use variable control chart for controlling manufacturing process. Next one is attribute control chart. If the characteristic under study is qualitative, then we use attribute control chart. Then we focus only on variable control charts. Other part attribute control chart we focus on next lecture. We discuss first one is type of variable control chart. Type of variable control chart. The variable, as we know, the characteristic under study is quantitative, that is continuous variable like height, weight, length. Then we use variable control chart. There are two types of control chart, that is RX bar chart, and next one is SX bar chart. For variable control chart, the aim of that means process variation, which is denoted by R. We should control the process variation from the manufacturing process, and also we control the central tendency of the manufacturing process. Then we see first chart, that is RX bar chart. In that lecture we only find out the control limits for R chart. Before that, we have to know the sample observation of the manufacturing process. So first we find out K samples, sample subgroups, K sample subgroups of size. So first we take from the manufacturing process, that is K sample subgroups of corresponding size. Then we find sample range. R should be sample range, which is calculated by largest observation minus smallest observation. Then we get values, that is values of ranges, that is R1, R2, and so on, R. Then we create the data in the following table, that is sample subgroup. These are the K sample subgroup, that is first one up to so on. Next we calculate corresponding range. We get values of R1, R2 up to so on. And next again we calculated means of sample subgroups, that is x1 bar, x2 bar, and so on, xa bar. These are the tabular form of corresponding range and means of the corresponding samples observation. So we calculate the control limits for R chart. For R charts. Then 3 sigma control limits value of, that is CL, nothing but expected value of R, lower control limit, which is nothing but expected value of R minus 3 times standard deviation of R. Next value is UCL, upper control limit, which is nothing but expected value of R plus 3 times standard deviation of R. For calculating these control limits, first we have to know what are the distribution, or what is the mean of corresponding range, or what is the value of standard deviation of range. So expected value, as we know, expected value of R, which is d2 sigma, and standard deviation of R is k d2 sigma. We put these values on corresponding control limits. We get CL, that is central limit, which is nothing but expected value of R, which is nothing but d2 sigma. Next one is lower control limit, which is nothing but expected value of R minus 3 times standard deviation of R from the above values, which is nothing but d2 sigma minus 3 times k d2 sigma. We take d2 sigma as a common, then we get 1 minus 3k d2 sigma. We put 1 minus 3k as a constant, which is denoted by d1 and sigma as it is. This is the LCL, lower control limit for R. Next we find upper control limit. That is UCL, which is nothing but expected value of R plus 3 times standard deviation of R. We put the expected and standard deviation values, that is d2 sigma plus 3 times k d2 sigma. We common again d2 sigma, we get 1 plus 3k d2 sigma. We put 1 plus 3k d2 value as a capital D2 and sigma as it is. This is the upper control limits for R chart. Here the situation arises, two situation arises, that is sigma is the process standard deviation. If it is known, then what are the control limits, and if it is unknown, then what are the control limits for R chart. Then first situation, that is standards are known, that is sigma is equals to sigma dash. Then CL becomes D2 sigma dash, LCL becomes capital D1 sigma dash, and UCL becomes capital D2 sigma dash, capital D2 sigma dash. Then second situation, that is standards are unknown, that is sigma, process standard deviation is unknown. Then we have to estimate the standard deviation, and the estimated value of process standard deviation is R bar upon D2. We put these estimated value on control limits, then we get CL is equals to D2 sigma hat. We put the estimated value, that is D2 sigma hat, nothing but R bar upon D2. Again D2 get cancelled, we get central limit of R control chart is R bar. Next we find lower control limit values and upper control limit values. That is LCL, which is nothing but 1 minus 3k D2 sigma hat. We put estimated value of sigma hat, that is 1 minus 3k D2 sigma hat, nothing but R bar upon D2. Again D2 get cancelled, we get 1 minus 3k R bar. We put 1 minus 3k as again next constant, which is denoted by D3 and R bar as it is, which is the lower control limits for R chart, which is nothing but D3 R bar. Next we calculate upper control limit. That is UCL, which is nothing but again 1 plus 3k D2 sigma dash, that is 1 plus 3k D2 into R bar upon D. Again D2 get cancelled, we get 1 plus 3k R bar, and we put 1 plus 3k as the next constant, that is D4 into R. These are the UCL upper control limit of the R chart. As we know, the values, that is we see, that is D2, D1, D2, D3 and D4 are the constant values based on size of the sample subgroups and which is given in the statistical table. For putting these values, we get all the control limits, that is if standards are known, we use these three control limits. If standards, that means process standard deviation, is known, we put these three control limits, that is R bar, D3 R bar and D4 R bar. By using these three control limits, we draw control chart for R charts, that is similarly we discussed last. On x-axis we take sample subgroups, that is here we put the values of ranges. On x-axis we take sample subgroups and on y-axis we take statistic. Here statistic nothing but our range. From the calculating value of CL, LCL and UCL, we draw three lines. First one is CL, next one is LCL, that is lower control limit for R chart, and this is the upper control limit for. These are the three lines of corresponding control limits. This is the central limit, this is the lower control limit and this is the upper control limit. Then we plot all the sample observation, that is value of R1, R2 up to so on Rk on same of graph paper, and we see that all the values are within the control limits, that is above LCL and below LCL. Then we conclude that the process is in statistical control. So next part of corresponding X bar chart and corresponding conclusion we will see on next lecture.